A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. You ever have that feeling where you open an app, maybe your banking app or a dashboard, and your heart just physically drops into your stomach? That cold spike of adrenaline, because a number is significantly larger than it was supposed to be.
I know that feeling intimately, Corn. It is usually followed by a very frantic session of checking logs and refreshing pages, hoping it is just a display glitch. You start bargaining with the screen. You think, maybe the decimal point is just in the wrong place, or surely this is just a projected cost for the next 10 years. But then the reality sinks in that the number is very real, very current, and very much your responsibility.
Well, our friend Daniel lived that nightmare recently. Today's prompt from Daniel is about cloud billing horrors, and he kicked things off with a personal sting. He got a bit loose with a Gemini API feature, thinking it was billed at the standard Gemini 3 rate. But it turns out the specific implementation he used was one of those premium tiers. Before he realized what was happening, he'd racked up a $300 bill.
Ouch. $300 is a very expensive oops for a personal project. And you know, by the way, today's episode is powered by Google Gemini 3 Flash, which is ironic considering we are talking about Gemini billing mishaps. But Daniel's $300, as painful as that is basically a rounding error compared to the absolute carnage you find on sites like serverlessshores.com.
Oh, I spent all morning on that site. It is like a digital graveyard of startup dreams and credit scores. It is fascinating because the very thing we love about the cloud, this infinite, elastic scalability, is exactly what makes it a financial landmine. If you can scale to 1 million users in an hour, you can also spend $1 million in an hour if your code is looping.
That is the double-edged sword of the modern stack. We have moved away from the days of, I bought a server and it sits in a rack, to, I have a credit card attached to a supercomputer that will give me as much power as I ask for, no questions asked. The problem is that the no questions asked part includes the bill. In the old days, if your traffic spiked, your server just crashed. It was a physical limit. The bill was just a broken website and some frustrated users. Now, the website stays up, but your bank account is what crashes.
It's the ultimate be careful what you wish for scenario. We wanted frictionless scaling and we got it. But the friction was the only thing keeping the bank account safe. I want to dig into why this is still such a massive problem in 2026. Why, after all these years of cloud maturity, is my serverless function bankrupt me still a headline?
It comes down to the fundamental architecture of these platforms like Amazon Web Services, Google Cloud, and Azure. They are designed for service continuity above all else. From their perspective, a hard cap that shuts down your service when you hit a budget limit is a failure. Imagine if a hospital's database just turned off because they hit a $500 limit during an emergency. The providers argue that customers would rather have the bill than the outage.
That sounds like a very convenient argument for someone who gets to keep the money from the bill, Herman. It's like a bar saying they won't cut you off because they don't want to ruin your night, but then they hand you a $10,000 tab for top-shelf whiskey you didn't realize you were ordering. But wait, if I'm an individual developer, I'm clearly not a hospital. Why can't I just toggle a I am not a hospital switch?
It's a bit of both, honestly. Technically, stopping a distributed system that is processing 100,000 requests per second is actually quite difficult to do instantaneously. There is propagation delay. By the time the billing system realizes you hit your limit and sends a signal to shut down the API gateway, another $10,000 of compute might have already happened. Think about how long it takes for a credit card transaction to move from pending to cleared. Cloud billing is often processed in batches, sometimes hours apart. By the time the stop command propagates through a global network of data centers, the damage is done.
So even if they wanted to help you, the speed of the disaster outruns the speed of the safety net. That is terrifying. It's like having a fire extinguisher that only activates after the house has already burned down to the studs. And speaking of disasters outrunning safety nets, we should talk about some of these specific horror stories. I saw one on Serverly Shores where a student was playing around with Firebase and a recursive cloud function.
Ah, the classic recursion trap. This is the hello world of cloud billing disasters. This student had a Cloud Run function that was supposed to update a document in Firebase, but the update in Firebase was set as the trigger for the function itself.
Oh no. So the function runs, updates the doc, which tells the function to run again, which updates the doc again.
It is a digital Ouroboros eating its own tail at the speed of light. In just 12 hours, that loop ran so many times it racked up an $8,000 bill. For a student, that is a year of tuition gone because of a nested logic error. And the kicker is, the function wasn't even doing anything useful. It was just changing a single timestamp over and over again billions of times.
See, that's where the sloth in me thinks we need a slow mode for development. Why isn't there a I am just a guy in a basement button that kills everything if it hits $50? If I'm building a hobby project, I'd much rather the site go dark for a week than have to explain to a debt collector why my to-do list app costs more than a used car.
Some platforms are getting better. Google actually just introduced some project-level spin limits this month in March of 2026, and they are supposed to start enforcing billing level caps tomorrow, April 1st. But for years, the only thing you had were soft alerts. You'd get an email saying, hey, you spent 80% of your budget, but by the time you read that email on a Saturday morning, the other 20% was gone 5 hours ago, along with your savings account.
It reminds me of that massive Amazon Web Services S3 outage back in 2017. People forget that wasn't just a technical failure, it was a financial one for some. One company ended up with a $15,000 bill for data transfer because their systems kept retrying failed requests over and over, essentially self-DDoSing their own billing account.
That is a great point. Retries are the silent killer. You write code that says, if this fails, try again, which is good engineering until the service stays down for 4 hours and those retries scale up to millions of requests. You are paying for the privilege of failing at scale. It's the exponential backoff that isn't quite backoffy enough. If your retry logic is too aggressive, you're basically paying Amazon to let you scream at a brick wall.
I also saw a story about a developer who left a Lambda function running overnight. Just one function. But he was doing some heavy processing, and he had the concurrency set to the max. He woke up to a $2,400 charge. It's like leaving the sink running, but the water costs $1 a gallon and the drain is blocked.
And it's not just compute. Data transfer is where the real hidden horrors live. There is a legendary story on the site about a company called Jmail that used Vercel for their front end. They had a surge in traffic, 450 million page views, which sounds like a dream, right? Viral success.
Until the invoice arrives.
The invoice was $46,000, just for bandwidth. Vercel's automated systems didn't throttle it in time. And there was another one, a different user, who hit $96,000 overnight for the same reason. When you are paying per gigabyte, and you suddenly serve petabytes because a botnet decided to crawl your site, you are in a world of hurt.
Wait, a botnet? So you can get a massive bill because of an attack you didn't even want. How is that even legal? If someone throws 1,000,000 bricks at my house, the city doesn't charge me a brick disposal fee for every one that hits my yard.
That is the S3 unauthorized attack, loophole. This one is particularly nasty. Even if you have a private S3 bucket that denies all public requests, Amazon still charges you for the request itself. So if an attacker knows your bucket name, they can spam it with millions of requests. Each one returns a 43 forbidden error, but you still pay a fraction of a cent for each of those denials. If they do that at scale, they can rack up thousands of dollars on your bill without ever seeing a single file.
That is essentially a financial distributed denial of service. A DDoS that doesn't just take you offline, but drains your bank account. That feels like a massive design flaw in how we think about cloud security. We focus so much on protecting the data, but we aren't protecting the wallet.
It's a shift in the threat model. In the old days, an attacker wanted to steal your data or deface your site. Now, they can just bankrupt you by making you use the resources you signed up for. It is the usage-based vulnerability. It's cheaper for a hacker to run a script that generates $100,000 in costs for you than it is for them to actually try and hack your encryption.
You know, it's funny you mention that, because we talked about this kind of scaling risk before. I'm thinking back to when we discussed serverless GPU cold starts in a previous episode. The whole point there was how to get things running fast. But the flip side, which we are seeing now, is that fast also applies to the billing meter. If you solve the cold start problem, and your AI agents can spin up instantly, they can also start burning through your GPU credits at a terrifying rate before you can even check the dashboard.
That is the perfect segue to the AI agent horror stories, which is a brand new category for 2025 and 2026. There was an incident involving an AI software engineer tool, I think it was Devon, where a team asked it to make a code-based change. The AI got stuck in a loop or started performing these incredibly high-intensity operations. By the time they checked, it had racked up over $1,200 in post-hog events in a single session.
The AI is literally spending your money to fix the code that is supposed to save you money. It's like hiring a contractor who accidentally leaves your industrial power tools running all weekend while he's at lunch. But what happens if the AI is autonomous? If I give an agent a goal and it decides the best way to achieve it is to spin up 10,000 worker nodes?
That's exactly what happened to a small research team last year. They gave an agent a data scraping task. The agent found a more efficient way to scrape by parallelizing the request across thousands of serverless containers. It finished the task in 3 minutes. It also cost them $4,000 in compute. The agent did exactly what it was told. It optimized for speed. It just didn't realize that speed had a linear correlation with bankruptcy.
Even worse is the bot-on-bot billing spiral. There was a documentation site, Mintlify, that saw a massive cost spike because their AI-powered search feature was being scraped by others' AI bots. One bot is trying to index the site by asking questions, and the other bot is charging the owner to answer those questions. It is just two machines talking to each other and billing a human for the privilege.
That is the most 2026 sentence I have ever heard. Two machines talking to each other and billing a human for the privilege. We have reached peak automation. It's a feedback loop of pure capital extraction.
It really highlights why the pay-per-use model is so dangerous for startups. If you are a big enterprise, a $50,000 surprise is a bad quarterly meeting. If you are an indie dev or a seed-stage startup, that is the end of the company. It's a heart attack-inducing email, as one founder put it. He actually ended up in the emergency room with physical symptoms after seeing a $100,000 Firebase bill.
I can believe it. The stress of realizing you owe a giant corporation more money than you have in the bank because of a typo, that'll give anyone chest pains. Imagine the conversation with your spouse. Honey, I accidentally clicked a button and now we don't have a down payment for a house anymore. It's a level of financial liability that most people aren't prepared for when they just want to learn how to code.
So, let's get practical for a second. We've sufficiently terrified everyone. How do we actually stop this from happening? Daniel got hit for 300, but how do you make sure it's not 30,000? Is there a checklist we should be following?
The absolute bare minimum, and I mean, if you don't do this, you shouldn't have a cloud account, is billing alarms. You need them at multiple levels. Don't just set one at your monthly budget. Set one at 25%, 50%, 75%, and 100%.
And don't just send them to an email address. You only check on Mondays. Put them in a Slack channel, or set up a PagerDuty alert if it's a production account. I've even seen people set up smart bulbs in their office that turn bright red when a billing threshold is hit. That's the kind of visceral feedback you need.
And beyond just simple alerts, use the anomaly detection tools. AWS has a specific service for this that uses machine learning to look for unusual spending. If your bill usually grows by $5 a day and suddenly it jumps by $50 in an hour, it will flag it even if you haven't hit your total. Budget yet. That is the early warning system that catches the recursive loops before they finish the job.
What about the nuclear option? Can I actually set a kill switch? Like, if the bill hits $100, delete the whole project?
You can, but you usually have to build it yourself. You can write a Lambda function that triggers when a billing alert hits a certain threshold. That function can then programmatically strip IAM permissions from your services, shut down your EC2 instances, or even delete the billing association. It's the kill everything button. It will take your site offline, but it saves your house. There are open source scripts on GitHub specifically for this. Look for cloud billing circuit breakers.
I feel like there should be a billing canary account strategy too. Like, have a separate account for testing with a strict $10 limit on it, so if something goes haywire, it only has access to a tiny sandbox.
That is a very smart move. Isolation is key. Never do your, let's see if this recursive function works, testing in the same account that has your production database and your primary credit card. Most cloud providers allow you to set up an organization where you can have multiple sub-accounts. You can actually set a hard budget at the organizational level for specific sub-accounts in some cases now.
It's wild that we even have to talk about this. You'd think the cloud providers would want to prevent this just for the sake of customer retention. If I get a $100,000 bill I can't pay, I'm not exactly going to be a long-term customer. I'm going to be a guy who declares bankruptcy and never uses your service again. It seems like bad business.
You'd think so, but there is a cynical argument that the revenue is too good to pass up, and they can always graciously waive the bill later to look like the good guys. Netlify did that with a $100,000 DDoS bill recently. They waived it, but the developer still had to go through that trauma first. Also, remember that for every one person who complains on Twitter and gets their bill waived, there are probably 10 others who just pay it because they don't know they can fight it.
It's the hero's journey of cloud billing. You start with a dream, you hit a nightmare. The giant corporation shows mercy, and you live to code another day. But now you have trust issues and 5 different billing dashboards open at all times. It changes how you code. You start being afraid of your own tools.
It really does erode trust. I think it's why we see some people moving back toward fixed cost, VPS providers like Hetzner or DigitalOcean for certain projects. You pay $5 a month, and if you hit your limit, the server just gets slow or stops. No surprises. No emergency room visits. You're buying a finite slice of a machine rather than a blank check for an infinite one.
There is something beautiful about a predictable bill. I'm a sloth. I like things that move slowly and predictably. This infinite scaling is too much for my heart rate. I'd rather have a site that crashes under load than a bank account that vanishes under load.
Well, the reality is that for a lot of what we do now, especially with these large language models and AI agents, serverless is the only way to get the scale we need. We just have to be better at building the guardrails. We can't treat billing as an afterthought anymore. It has to be a primary part of the architecture. You have to architect for cost just as much as you architect for latency or availability.
Architecture for the wallet instead of just architecture for the user. That should be a certification.
Precisely. If you are building an AI agent that can make its own API calls, you have to treat that agent like a junior developer with a corporate credit card. You wouldn't give a junior dev a card with no limit and no supervision, right? You'd give them a card with a $200 limit and tell them to call you if they need more.
I wouldn't even give most senior devs that. I've seen what they order for lunch. They'll spend $50 on artisanal toast and not blink an eye.
Fair point. But seriously, setting API quotas is another huge one. Don't just rely on the billing alert. Go into the Google Cloud Console or AWS API Gateway and set a hard limit on requests per day. If your app is only supposed to have 100 users, set the limit to 1,000 requests. If it hits that, it stops. That is a hard cap that actually works and is easy to set up. It's much simpler than a complex Lambda kill switch.
That's a good one. It's like putting a governor on a car engine. It doesn't matter how hard you hit the gas, the car is only going to go 60. It's a physical constraint on a digital system.
And, for the love of everything, check your model names. Daniel's mishap with Gemini was likely a model name issue. In early 2026, the pricing for Gemini 3.1 Pro Preview is significantly higher than the budget-friendly flashlight. We are talking like a 40 times price difference. A single typo in your configuration file can turn a $10 experiment into a $400 bill overnight.
40 times? That is insane. Imagine if you went to the grocery store and a gallon of milk was $4, but if you accidentally picked up the one with the blue cap instead of the green cap, it was $160. And they don't tell you until you swipe your card.
And the milk looks exactly the same. That is the problem with these API tiers. The output looks the same to your code, but the backend is using vastly different amounts of compute. You might be getting slightly better reasoning from the Pro model, but for a simple Hello World test, you'd never notice the difference until you saw the invoice.
It really makes you wonder if we will ever see true provider enforced spending caps as the default. Like, when you sign up, you have to opt in to infinite scaling instead of it being the default. It feels like we're currently in the Wild West phase of cloud billing where the house always wins.
I hope so. But until then, sites like serverlesshores.com will keep getting new entries. It's a great reminder that in the cloud, someone is always paying for the electricity. If you aren't careful, that someone is going to be your future self's retirement fund. There's a certain irony in the fact that we built these incredibly sophisticated systems to manage data, but we're still using 19th century surprise billing tactics.
On that cheery note, I think I'm going to go double-check my own alerts. I have a few Gemini experiments running that I suddenly feel very nervous about. I might even go as far as to just turn them off until I've read the pricing page 3 more times.
Good idea. Maybe check them twice, and maybe check your S3 bucket names while you're at it, just to make sure you aren't being financially DDoSed by some script kiddie in another time zone.
Well, this has been an enlightening and slightly terrifying look into the dark side of the cloud. Thanks to Daniel for the prompt and for sharing his sloppy moment so we could all learn from it. It's a brave thing to admit. You blew $300 on a typo.
And thanks to our producer, Hilbert Flumingtop, for keeping us on track and making sure our own recording costs don't spiral out of control.
Big thanks to Modal for providing the GPU credits that power this show. And thankfully, they have some pretty great tools to make sure we don't end up as a story on Serverly Shores ourselves. Their dashboard actually makes sense, which is a rarity in this industry.
This has been My Weird Prompts. If you are enjoying the show, a quick review on your podcast app really helps us reach new listeners who might need to hear these billing warnings before it is too late. Seriously, you might save someone's life, or at least their credit score.
Find us at myweirdprompts.com for the full archive and all the ways to subscribe. Stay safe out there and watch your API keys. Don't let your code spend money you don't have.
See ya.
Bye. This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the flows from sloth.